And one more example on hierarchical models. We're going to look at this multinomial Dirichlet example. So multinomial is a generalization of binomial. Um, and Dirichlet is a generalization of beta. So Dirichlet is essentially multivariate beta distribution. Multivariate beta. Okay. And the Dirichlet will be used as a prior. Multinomial going to be used as a likelihood. We're going to model outcome of elections. This is 2012 elections. Obama versus Mitt Romney. Oh, my pencil stopped working. So essentially we have n equals to 2. So there are two possible outcomes in each of the states. And we have 51 states. And essentially, multinomial distribution, you can think of it, you throw a dice in each of the states, and dice or coin has two sides, Obama side and Romney side, and you basically want to know the joint distribution across all of the states. So PI in this case is the expected value that Obama wins, state I. And the joint distribution over the P's is that what we're interested in, and we're going to use the Dirichlet prior. Again, Dirichlet is just generalization of beta distribution, and it is assumed that in each of the states, P's will have to sum up to 1. And we assume flat and informative prior, lambda equals to 1. And then what we're interested in the probability that Obama wins state J given the data, so the posterior over the probability of the win. And then, of course, we're interested in the outcome of the election, probability that number of electoral votes collected by Obama is greater than 270 given the data. And we can calculate the point estimate. It's just going to take the weighted sum of the electoral votes. So EVJ is the electoral vote for state J. And then we have expected value over PIJ, so expected probability of winning the state given J. So we can get a point estimate this way. But since we're doing the Bayesian approach, we would be more interested in getting some type of intervals, or maybe looking at the histograms and looking at the distribution over Obama's chances of winning. And one side remark here is that so in our model, multinomial Dirichlet, the posterior over P1, P2, P51 given data is also Dirichlet. And if you know the joint over values of P, you can calculate the marginal. So the value, so distribution over each of those Pj actually gonna follow the beta distribution. And the parameters of this beta distribution is just, so it's alpha plus P hat. So let's say it's Dirichlet with alpha plus P hat, and we're just gonna call alpha plus P hat to be alpha hat, and it's just a vector with 51 entries. So, and the beta distribution will have parameter alpha j, and then sum across alpha j's, alpha i's, for all i's not equal to j. So that's the marginal from. So we know the probability of Obama winning each state, and what we can do. So this is the data set that we use to estimate our model. Again, in our Dirichlet, we use prior alpha equals to 1, and then we use this data set to estimate the posterior, our alpha hat equal to alpha plus P hat, and P hat is just estimated proportion of the voters in each of the states or alpha I equals to 1, alpha I equal to alpha I plus pi hat, and again we have 51 states in the observation. And then we can do some Monte Carlo simulation. So the way the Monte Carlo simulation works, we just go all across all of the states and we draw from this marginal distribution whether Obama wins or Romney wins. And so we run many versions of those simulations, and then each time we run a simulation of the election, we calculate the number of electoral votes, and what you see is the histogram that comes out of this of the simulation. And this is a smooth version of the histogram, so that's basically the density plot. And our expected or average value calculated for Obama was around 300. No, sorry, that's not expected. That's the actual outcome. No, that's not the actual outcome. Actual outcome 2008 was 370 and 2012 was 332. So 332. So this is 2011 elections. That was the actual outcome. And you see most of the observations in our simulations would be on the right of 270. So our simulations correctly predicted that Obama will win the elections. So essentially, this is our version of how Nate Silver does those type of prediction by pooling or shrinking the results from multiple polling stations.